Good afternoon, everyone. Now here we can design our project, that is the PIC LED microcontroller. LED PIC microcontroller. And then how to design the PIC microcontroller? In that you can use the ISIS protease here. This icon is ISIS protease. In that protease, you can design the any circuit diagram. Firstly, uh, you select the file and then new design. In that new design, by default design is saved. So here you choose the here P. In that firstly you use the PIC microcontroller. PIC, you know that the PIC the series of the PIC microcontroller is 16F77A. We use the PIC 16F77A. Here this microcontroller, choose here and then you select the OK. Then press here the PIC microcontroller. Okay, this is the PIC microcontroller. Then in that PIC microcontroller, you very important for the clock and reset circuit. In clock and reset circuit, you importantly some capacitor, resistor and the crystal there. Then here you can choose the that's some component here. Firstly we give the resistor, here resistor, then okay, you give one resistor here and then press it here the resistor. Then you can also rotate off this component here. Click the right click option and then rotate this component, it is the clockwise or the anti-clockwise. Then you use the capacitor. Here you select one capacitor and then OK and press here the capacitor. Then it also rotated by anti-clockwise. And then you know that the in reset circuit the resistor, capacitor and the one switch is needed. Then you use one switch here. Switch, then OK and press it switch. Then it rotate the anti-clockwise or the 180 degree. Then here you know that the resistor is connected to the power. Here we choose this power. Then these components are connected by using these pencils. Here connected these two components. Then ground it, the capacitor, and then connected to the ground. You know that the switch is connected to also ground and the capacitor. And then this is the reset circuit is connected to the pin number 1 of the PIC microcontroller. Then this is the reset circuit. You also rename that this power, that is the VCC here. Okay. Then you know that the you also need the clock circuit of this PIC microcontroller. Then you use the clock circuit for the many component, that is the capacitor and the some crystal here. Firstly we do the crystal, quartz crystal is give there. Then OK, then press it here the crystal. Then crystal is also rotated by the anti-clockwise series. Then here two capacitors are needed here. You can use here the capacitor. here. Then this capacitor is connected to the pin number 13 of the PIC microcontroller, that is the clock circuit of the PIC microcontroller, and second capacitor is connected to the next capacitor, and then this crystal is connected between these two capacitors, and then this two capacitors are grounded here. Then you use the ground and is connected to this to ground. Then crystal is, you know, that the 32 megahertz frequency. You can select this frequency. Okay. You know that these two capacitors of the clock circuit is 22 picofarad. You can choose the this. You can also edit of this component values, that is here 22 capacitor, 22 picofarad capacitor. Okay. Then you know that the our practical is connected the LED of the PIC microcontroller. Connected the LED. Then you use the LED here. One LED is here. Select a LED. Okay. Then connected of this LED. Here in that program you use the port C. Port C is output mode. Then you in that notice you are also connected this LED to the port C. If here port is changed, then some errors are occurred is that. Then second pin of that LED is connected to the grounded. Then okay, this is the completed circuit diagram of the interfacing the LED to the PIC microcontroller. Then how to build the programming that, then you can double click that PIC microcontroller, then you choose the file here, then you here save the program in that our folder. You know that your folder is, you gives your name, new LED PIC. Hex file is here created, then this hex file is loaded in that PIC microcontroller. Then here also set the frequency, that is the 32 megahertz. Then okay, then save it is, and then run this circuit. Okay, here LED is on. LED is on. Then also you know that LED is on and off. Then some changes are in the program. You know that the LED is on and off here. Then you can use the same delays here, that is the here you type the delay, that is the MS delay. Some delay is here. And then off the delay. Off means here 00 there. Then here delayed function is also included in their void. MS delay. Unsigned integer delay. Unsigned integer delay. Then this subroutine is including here. You know that the program of the LED, the on of the LED. Then here while one. Delay minus minus. Then here our delay subroutine is completed here. Then save of this program and then again build it program. Some error is there, then error is here, some error are found, then you can use these messages windows here. The program is completed successfully. Then this is rebuild all the sources for the making the hex file. Then you open the ISI protein, then stop this simulation and then loaded again this changing the program, that is the new LED with .c hex file is here. Okay, then save it and run, and LED is on. That is the interfacing of the LED PIC microcontroller is completed.